Welcome back to the Cute Developer. Today is exciting. We're talking about ASCII risers. It's going to be a C++ console game. The code first begins by including our usual header files with a few extras. It'll include IOStream, which is essential for input and output. Vector, it'll be used to create dynamic arrays. A string, in conjunction with a vector, it'll be used to represent the rows of the map. The thread will be used. It'll provide capability for pause and program execution. Chrono will be used for high resolution timing. And termios, well, that's a way to get the I/O settings, the raw key presses. This way we'll not have to wait for enter. The uinst, well, that's going to provide operating system and specific to select functions, and that'll be used for blocking input. stdio, some more I/O functions. They're used for file NO and other constants that we're going to need. Now the constants, map width, map height, player char, empty char, wall char, those are all going to be used for the width, the height, the character, and the primary character for immovable objects. So to continue down the path, I'm going to create a vector of strings. That'll be the map. That'll be the game world. I'll create float X and float Y for the player. That'll be for the player's position. Using floating point numbers, it gives the ability for smooth movement and realistic physics calculations. The game logic, well, it'll be needed in order to render the tile-based collisions and when you're checking. Now the floating velocity, that's the vertical speed of the player. Set a boolean for the on ground just to check to see if it is on ground, and an edit mode to toggle back and forth between edit mode and play mode. The edit cursor X, edit cursor Y, that's the integer coordinates for the cursor, and that will be done when in edit mode. Now the terminal input, well, this is going to be the magic, the raw and non-blocking I/O. This is probably the most complex and most annoying at times, depending upon the operating system, because it is dependent upon operating system. Now this is specific to Linux, because I like Linux. Now the standard terminal, well, it requires an enter to be sent to the command. So to make the game responsive, we need non-blocking input. That's what POSIX uses. So now I'm going to say set the terminal mode. That'll configure the terminal. Now the struct terminos, that's going to store the original settings so they can be restored later. The TC get attributes, well, that's going to save those current settings. So in the exit function, 8exit, reset terminal mode, ensuring the terminal is always reset even if the program crashes or quits early. Now the modification flags, new IOC, iFlag, and the iCannon disables the input buffer and allows the characters to be read immediately. Echo prevents type D characters from being displayed on the screen. Now the non-blocking input, get input, this get input function is going to pull the keyboard to check to see if a key is pressed. But it doesn't wait indefinitely. It's non-blocking. Now fd set fds, that structure is used to select a function. Well, it selects the function on the monitor. It then checks the descriptors for activity. Now the struct time val, that's going to set a 0 timeout for select. So what that means is it's going to return immediately, whether there is input or not. This is what makes the input non-blocking. Now the null, well, the select, my if statement, if select std in, we're going to check to see if there's any data ready to read. The std file no is going to return greater than 0. It means the key was pressed. So then we read it. If a key was pressed, the function reads a single character. It reads it into variable C. The function is going to return a character if the key was read, or 0 otherwise. Now we need to ensure the game doesn't pause waiting for the user input. That's why this is important. Then we go to the initialization. Need to initialize the map. Now that function is going to start the initial layout. That'll be the game world. It's going to clear any previous maps. Map.clear. Now it'll iterate through the height and width, construct new row using the std string row map width and empty char. It sets up the initial environment. The bottom row is always the floor. That's where the y equals map height minus 1. It creates a few simple platforms and specific coordinates. This is the level design component. So the is colliding, this function is going to check if the tile coordinate, well, if it's a collision. It first checks if the coordinates are out of bounds. If so, it returns true. An implicit wall surrounds the map. Then it's going to check the map character. It's going to check it at the given position. And that's with the map x, empty char, etc. If the character is anything other than an empty space, the function returns true. It's going to indicate a collision. Now the game logic and the physics, update game, this is going to be pretty exciting. This is where the update game function is the heart, it's the heart of the physics simulation. It's the game state progression. It runs once per frame. Now, if it's in edit mode, it's going to return. The game physics is disabled while in edit mode. So take a look at the time step, pass dt to it. Now the function takes the dt, which is the delta time. The elapsed time, now going back to the delta time, that's just kind of a universal name that's given. Everybody uses delta time, so I figured I would too. It'll take the elapsed time, or the elapsed since the last frame, takes that as the argument. Now this is going to ensure that the game runs at the same speed regardless of the processing power. This is important. Now this concept is called frame rate independence. Now the gravity, velocity y, that's going to be plus or minus 20 frames. Multiply that times dt. Now, gravity is a constant acceleration. So the 20 tiles, modulus 2, it's going to be applied over the time interval of dt. Now that'll accumulate into the vertical velocity. Now terminal velocity, y, that's got to be greater than 10. And the f at the end, 10.0f, well, f is for float. Velocity y is going to equal 10.0f. It's going to limit the player's maximum falling speed. You want to prevent them from falling so fast that they might just tumble through the platforms. Now we look at the y movement and the collision. A potential new y position. New y, well, that's calculated. Now p new is going to equal p current plus the v current times the dt. The code determines which tile the player would hit next. Not like to, but would actually hit next. Then you can look at the next tile. It'll base it on the direction of travel, up or down. If a collision is detected, well, it's collided. If the player was moving down, the velocity is greater than 0, it landed. Their position is snapped to the tile above, and the collision tile, player X, equals the next tile. And that ground is set to true. Now, if the player was moving up, well, the velocity y is less than 0. They've hit a ceiling. Their position is snapped to the tile below the collision tile. In both cases, velocity y is reset to 0. Now if there's no collision, the player's position is updated. And this, well, on the ground is set to false. Now we need to look at clamping. Clamping, the player's position is restricted to within the map boundaries. That's clamping. It's going to prevent them from moving permanently off screen. There's no wraparounds. Now the input handling, well, that's going to process the input. And the input function, well, it's going to check for a key press, get input, and it'll execute the corresponding action. We'll begin to check the keys. If the key is Q, then I'm going to exit. And the edit mode. Now the WASD keys, those are going to move the edit cursor. So the X, the Y, it's going to move the map around. Now the STD max and STD min, those are going to be used to clamp the coordinates within the boundaries. 1, 2, and 3 change the character of the tile at the cursor's location. This is going to allow the user to draw a map. E, lowercase e or uppercase e, well, that's going to edit the mode, or exit the edit mode. Tongue-tied. So I'm going to include, the checks, because if the player's original position is now inside a wall, the player has moved back to the starting point. We then need to jump to the game mode input. Horizontal movement. A and D will be used to control those. The horizontal calculation is slightly complex. It's going to involve DT, but in a simplified, non-physical accurate way, well, player X plus 1.0f, it's going to multiply that times 1.0f times the 60 frames per second times the 100. So, simplified, it's the frame rate conscious velocity. So, collision, it's got to be checked for the adjacent tile. If it clears, the player position is updated. Now we move into the jumping. The jump action is only processed if the player is currently on the ground. Velocity Y is set to the negative value, -8 tiles. It's got to initiate the upward movement, which, of course, gravity immediately begins to counteract. Now the is on ground is set to false to present mid-air double jumps. E and E, the edit modes, well, that's setting the cursor to the player's current location. Now I gotta render the scene. This function is responsible for drawing the current state of the game to the terminal. Now the screen clear, well, that's going to just clear the screen. Now the crazy code of 0332 clears the entire screen. 033 with the H, it's going to move the cursor to the home position, top left corner. Now this sequence is what makes the game appear to be animated. As the screen is redrawn completely, it gets drawn from scratch every frame. Now map drawing the loop. The nested for loops iterate through every coordinate on the map. Drawing the order, layering. Now the drawing logic prioritizes the object based on their importance. So for each player, if the current tile coordinates match the player's rounded integer position, then the player char is drawn, but only if it's not in the edit mode. Now the edit cursor, if it is in the edit mode and the coordinates match the cursor's position, the tile's character is drawn using the ASCII 033 7M. It's for the inverse video highlighting, followed by 033, which is reset to 0, and then the color. So now we take a look at the status in the help text. This needs to display the game console, or the game mode I mean, and its key bindings and the player's coordinates, providing the crucial feedback which the user needs. Next is the gain loop. That's the main function. That initializes the program and controls the entire execution flow. So the set terminal mode, it's going to set the terminal to the raw non-blocking mode. Initialize the map, loads the starting level, the frame rate control and the time tracking. Well, to achieve this smooth, consistent frame, the fixed step approach is better, but this is a solid approximation. The code will implement a capping mechanism. The auto last time, well, that's going to store the time of the previous frame. And the target frames per second, we'll set that to 60. That sets the goal frame rate. My auto frame duration, that's going to calculate the ideal time one frame. Well, that's what should take 60 seconds of a second. Or 60 frames of a second, sorry. The while loop, that's just going to run through everything. That'll remain true until it's set to false. The delta time calculation, that's going to be the chrono duration, and that's going to set the current time minus the last time, and it'll calculate the actual time passed. My delta time count, that'll be set to dt. That'll extract the time in seconds. My last time will equal the current time, and that'll save the current time for the next iteration. I then need to render the game loop as executed. Call that process input, that'll check for the input. The update game, I'll pass dt to that, delta time. Then I'll render. Now if the elapsed time is less than the frame duration, well, I then know it took less time for the target frame duration. I'll pause. When I sleep, this will ensure the loop, it doesn't burn CPU cycles. Now, time to run it. But this is a mixed modern C++, like chrono, vector, which creates functional, interactive terminal game using a map editor. This showcased many principles of software development and some console game programming. Hope you enjoyed it. Please leave a comment. Let me know what else you'd like to see. Thank you for watching, and keep typing.